All right. So let's talk about 3.2. I'll have these notes posted for you with this lecture, so you can print these off and kind of follow along. So this is going to be applications of radian measure. One of the big applications of radian measure is arc length, because if theta is given in radians, then the arc length s of an arc intercepted on a circle of radius r by theta is just r times theta, right? S, the arc length, equals the radius times the angle, right? So s equals r theta. Theta has to be in radians. But here's a proof of this. It's really easy, right? If theta is in radians, then theta equals s over r, just by definition, right? That's how we defined radians. So you multiply through by r, and you see that s equals r times theta. So the arc length is just radius times the angle. So for example, a circle has radius 18.20 centimeters. Find the length of the arc intercepted by a central angle having each of the following measures. So we'll do 3 pi over 8. So we have an angle of 3 pi over 8 radians. The question is, what's the length of the arc intercepted by that angle? So here's kind of a rough sketch. So you've got some kind of circle, and then you've got some angle, 3 pi over 8 radians, and you want to know what's this arc length right here. So that's s. Okay, so we want to know what that arc length is. Well, you know that the radius is 18.20 centimeters, and so s equals r times theta. That's just 18.20 times 3 pi over 8. And we'll round our answer here to 4 sig figs, since that's the measurement that we were given. So let me pull out my calculator. So let's see. 18.2 times 3 pi over 8 is approximately 21.44. Okay, so that's that. So normally for a problem this simple, I probably wouldn't draw a picture, honestly. So let's look at the next one. So this one says the angle is 144 degrees. So the trick here is that before you can use the arc length formula, s equals r theta, you need to change theta into radians, right? So in the first place, we're going to take 144 degrees, we're going to change it into radians, okay? By doing that, 144 divided by 180 is 4/5. So this is 4 pi over 5 in radians, okay? Radians. So the arc length intercepted by that angle is going to be 18.20 times 4 pi over 5. So that's about 45.74. Well, I guess this time we should use 3 sig figs, right? Since we were only given 3 sig figs to start. So we'll say 45.7 centimeters. Okay, so that's how that works. Here's another example. It says latitude gives the measure of a central angle with vertex at Earth's center, whose initial side goes through the equator and whose terminal side goes through the given location, right? Okay, Reno, Nevada is approximately due north of Los Angeles. The latitude of Reno is 40 degrees north, and that of Los Angeles is 34 degrees north. The radius of Earth is 6,400 kilometers. Find the north-south distance between the two cities. Okay, so here's how I'm imagining this scenario. Okay, latitude gives the measure of a central angle with vertex at Earth's center, whose initial side goes through the equator. Okay, so we'll say that's the equator, and whose terminal side goes through the given location. So the first location that we're given is Reno, which is 40 degrees north. So maybe this is Reno, okay? And and that's a 40-degree angle right there. And then Los Angeles is 34 degrees north, so maybe this is LA, okay, and that's a 34-degree angle. So this is 40 degrees, and this is 34 degrees. And what we want to figure out is, what is this distance, this north-south distance between Reno and Los Angeles? So what's that distance? What's that arc length, in other words? Well, first of all, it's pretty clear that this angle should be 6 degrees, right? 40 degrees minus 34 degrees is 6 degrees. So the angle that we're interested in is a 6-degree angle. We've got to change that into radians, though. So we'll say 6 degrees times pi over 180 is pi over 30 radians. And so then we can get the arc length, right? Arc length is r times theta. It says the radius of the Earth is 6,400 kilometers. So that's going to be 6,400 times pi over 30. And it looks like we've got 2 sig figs everywhere. So we'll round to 2 significant digits. 6,400 times pi over 30 is about 670 kilometers. So to suit 2 sig figs, we'll say 670 kilometers. Okay, so that's that one. What else do we have with arc length? Ooh, okay, so we have some interesting, like, pulley type of things as well. This one says a rope is being wound. That should say wound. Wound, too many O's. But a rope is being wound around a drum with radius 0.8725 feet. Okay, how much rope would be wound around the drum if the drum is rotated through an angle of 39.72 degrees? Okay, so here's how I'm imagining this. So the drum, it says, has a radius of 0.8725 feet. Right, so that's that radius right there. And it says it's going to rotate through an angle of 39.72 degrees. So so it's going to rotate, like, let's say that this is the where the rope kind of, you know, makes contact with the drum or whatever. If it rotates 38.72 or 39.72 degrees, then it ends up kind of right there, and that's a 39.72 degree angle. And so the question is, how much rope will be wound around the drum? In other words, once again, we're looking for this arc length right here. So the first thing I'm going to do is change the angle into radians. Okay, so let's see. So let's do 3,972 divided by 180 and then 2 extra zeros. Okay, that would give us 331 pi over 1,500. I'm doing it this way so that, so in other words, I divided 3,972 by 18,000, right? I moved the decimal here, so I moved this decimal, so I added 2 zeros on there. And the reason I did it is so that I wouldn't have a decimal as my answer. I don't want a decimal. I don't want to round this off at this point in the calculation, because then I'll have rounding errors in my final answer. So I want the exact value, and that's the exact value of the angle. But so now I can find the arc length. I can say, well, S is going to be 0.8725, right? That's the radius, r, times theta, 331 pi over 1,500. And now this one I'm going to go ahead and round, and I'm going to round it to 4 significant digits. That's the number of sig figs that I started with. So we'll do 0.8725 times 331 pi over 1500. Okay, so that comes out to 0.6049 feet. So that's the length of rope that would be wound around the drum. Okay, let's do another one. Maybe this one's slightly more involved. It says 2 gears are adjusted so that the smaller gear drives the larger one. The smaller gear has a radius of 2.5 centimeters and the larger one has a radius of 4.8 centimeters. If the smaller gear rotates through an angle of 225 degrees, through how many degrees will the larger gear rotate? Okay, well, so I'm not going to try to draw gears that are interlocking. I'm just going to draw them as kind of simple circles. But you've got a small gear, and then you've got a larger one. So you've got some kind of situation like this. Just pretend that these circles are actually circles and not ovals. Okay, but they're touching. Now the small gear is going to drive the larger one. The small gear has a radius of 2.5 centimeters. 2.5 centimeters. That was sloppy. 2.5. The larger one has a radius of 4.8 centimeters. Okay. The smaller gear rotates through an angle of 225 degrees. Now, here's the key. The arc length on the small circle has to match the arc length on the large circle because the small circle is driving the large one, so they're going to go through the same amount of distance. Both gears are going to go through the same amount of distance on their outer edge. What's different is that in order to go the same distance on the outer edge, because this gear is smaller, it's going to have to travel through a larger degree than this one will. And so that's exactly the question we're asking, is through how many degrees will the larger gear rotate? So in order to figure that out, I think first of all, we should find the arc length on the small circle. And once we find the arc length on the small circle, we know that that has to be the same as the arc length on the large circle. And then we can use that to figure out through how many degrees the large circle rotates, the large gear rotates. So for the small circle, so the arc length of the small circle, that's going to be the radius of the small circle times the number of degrees, or the angle through which the small circle rotates. But we've got to change these degrees to radians, right? So I should have done a little bit of scratch work. I'm going to squeeze it in up here and say 225 degrees times pi over 180. 225 over 180 is 5/4. This is 5 pi over 4 radians. So I'm going to multiply by 5 pi over 4 here. Okay, and let's see, 2.5 times 5 is 12.5. So I'm really going to do 125 divided by 40. That gives me 25/8. So this is 25 pi over 8. Okay, so that's the arc length through which the small gear rotates. Well, the arc length through which the large gear rotates is the same. Small. That's 25 pi over 8. Okay? That has to equal r for the large gear, which is 4.8, times theta for the large gear, which we don't know. That's what we're trying to solve for. So we're in good shape now. We can go ahead and divide through by 4.8. So we're going to say, and this time I'm going to go ahead and round. So I'm going to say 25 pi over 8 divided by 4.8 is about, how many sig figs? Well, actually, we want to take this back to degrees, don't we? It says through how many degrees will the larger gear rotates, and the answer I'm being given here is in radians. So, on second thought, maybe I want to leave it in its exact form, at least for now. So, we would get theta equals 25 pi over 8 times 4.8, right? So let's change that to degrees now. I'm going to multiply by 180 over pi. So the pi's at least will cancel. So let's see. So theta is going to be 25 times 180 degrees over 8 times 4.8. That's going to be the exact answer. So let's go ahead and round this one now to, I think, 2 sig figs. So we're going to have 25 times 180 over 8 times 4.8. So to 2 sig figs, so I'm getting 117.188, but to 2 sig figs this would be 120 degrees, right? So if the small gear has to go through 225 degrees to move the large gear, the same distance, then the large gear would go through 120 degree rotation. Okay, so that's arc length. Another application of radian measure is the area of a sector. So a sector of a circle is the portion of the interior of the circle intercepted by a central angle. So here's a picture, right? So this is a sector. It's like a little wedge, like a little piece of the circle, a little piece of the pie. Okay, so the area A of a sector of a circle with radius r and central angle theta is A equals 1/2 r squared theta, where theta is in radians. Okay, here's a proof that you can read through if you'd like. Let's just do this example. So this one says a sprinkler sprays water 15 feet in a 35-degree pattern. What is the area of the sector watered by this sprinkler? Okay, so you've got some sprinkler, I guess, and it waters, a certain sector like that, right? And it does so in a 35-degree pattern, and it sprays 15 feet. So the radius is 15 feet, the angle's 35 degrees. We're going to have to change the angle to radians, so we'll say 35 degrees times pi over 180. That's 7 pi over 36 radians. So the area of the sector is 1/2 r squared times theta. And we'll go ahead and round this to 2 sig figs. So I'm going to go ahead and pop this into my calculator, but this should be 75. Not 75. Let me write this again. A is 1/2 r. R is 15 squared theta. There we go. Okay, so let's see. We're going to have 1/2 times 15 squared times 7 pi over 36. That comes out to about 69. If I'm rounding to 2 sig figs, we would say about 69 square feet. That's about how much that sprinkler waters. About 69 square feet of land. And I think that's it. Yep, that's it. So not a ton of stuff in this section, just mainly arc length and area of a sector.